Hey all you cool cats and kittens. Today we're going to talk a little bit more about indefinite integrals. So I'm going to start by showing you an example that probably comes across as should be really easy, and it is really easy, but I want to use it to develop a rule. So we've got, let's say we have an integral of some quantity, so 2x plus 1 squared. Okay, and we want to integrate this. And I think that probably the most common first thought would be to use the integral rule for power rule. So we would say 1/3 times 2x plus 1 to the third power plus c, right? So I want to talk about now why that's not correct. So the first thing I want to do is go back over to the side and then talk about kind of what the last video said is simplify this. So what do we mean by simplify it? So we've got 2x plus 1 squared. So if I take this and I simplify it, right, it's really the integral of 4x squared plus 4x plus 1. I foiled if you are confused. Right? And so then if I were to now integrate this side, right? So I'm just going to keep working this way. We're going to see if we can get it to match. So if I apply the integral to 4x squared plus 4x plus 1, I'm anti-deriving this. So it would be 4/3 x cubed plus 2x squared plus 2x plus c. So we know for a fact that this one is correct because we started by simplifying and then we applied the integral to each individual terms, and we were allowed to use the integration rule for power rule. So now if this is correct, these two sides should match. So let's see if we got it right. So I'm going to use binomial expansion here. I'm going to use Pascal's triangle or binomial probability, not probability, binomial coefficients. There we go. So that would be 8x cubed plus 3 times, so 4x squared times 1 plus 3 times 2x times 1, finally plus 1 cubed plus c. Alright, so still a simplification. So this first term we can already see something's not right. So we've got a mistake somewhere, right? And we know that there's a mistake somewhere, so let's figure out where that is. So the next term, so 12x squared divided by 3 should be 4x squared. Still another term that is not correct. Okay, last term, well, linear term. So 6x divided by 3, 2x plus 1/3 plus c. So here we can see that both of these are making up the constant, so that's what this constant here is standing for. We're going to talk a lot more about the constant later, not quite yet. So are we seeing a match? So here, and if we just look at the parts that we know to be true, so I'm erasing the constant from here, meaning I'm going to erase this constant from there for now as well. So what's the difference between these two answers? And what we're seeing, hopefully you can see this, is that this one, which we know is incorrect by a factor of 2. It's every term is 2 times as big. Wait. Oh. Oops. So every term is 2 times as big. That should just be 1x, not x. My bad. Alright, so we can see each of the terms is doubled over here. So why is that happening? So let's go back to the original problem. If we think about this, at the very beginning, what we're given is a derivative. So 2x plus 1 to the second power is a derivative of something. So if we look over here, if we were to take the derivative of that problem, so if we go back, I have a different color. If we go back up here, the derivative of this take the derivative of this, what I end up getting is 3 times 1/3 2x plus 1 squared, but I have to use the chain rule times 2. So that wasn't the problem that we got. We got the 2x plus 1 squared, we didn't get the times 2. So, sorry, there's a glare. So how do we get rid of that times 2 in the original problem? What had to have been there before the derivative was taken in order for that 2 to disappear? Well, how do you get a 2 to go away? We can't subtract. What is it doing? It's being multiplied, so we would have to divide by 2. And another way of saying that is to multiply by 1/2. So at the very beginning, if we wanted to use this rule, instead of simplifying it this way, if we wanted to do the inverse of the power rule to take the integral of this, we would have to multiply it by 1/2. And the reason for that is because there's no 2 that this is getting multiplied by, and there had to have been if this is a chain rule problem, and it is. So I'm multiplying by 1/2, so I'm just going to put that right out front, the 1/2 times the 1/3. So essentially I can still do this, except now the final answer would have to be 1/6 times 2x plus 1 cubed plus c. So that is what the correct answer should be. You guys can see that? So we can verify that this is true. The only thing that's different is this coefficient. It's 1/6 instead of 1/3. All of this remain the same. So now if I go back through and distribute the 1/6, so 8/6, right? 8/6 is 4/3. This is 12x squared divided by 6. That's 2x. This is 6x divided by 6, which is a single 1x. And then plus our constant, in this case it's 1/6, plus that c. Again, for now, just want to see that plus c. So what we're showing is we can get the right answer, we just have to do a little thinking about it before we just barf out the inverse of the power rule. Alright, so the process that we use for problems like this, so that you don't have to do the simplification, and again, this one's fine doing the simplification because it's just to the 2nd power, but imagine if it wasn't. Imagine if it was to the 10th power or something crazy like that, or we had a root or something different. So we want to be able to develop a generalized rule to make our lives easier. So we do use substitution for this. And this might seem a little bit weird, but try to hang out with me for a second. So same problem, but now what I'm going to do is introduce the letter u. And this is the standard way of doing this. Why do we pick the letter u? I don't know. So u is 2x plus 1. And so if I wanted to take the derivative of u with respect to x, so I take the derivative of u with respect to x, I would get the derivative of each of these terms is 2. So what I want to do is go back up and substitute. So I'm substituting in whatever I can. So this is the part that's a little strange, so you might have to watch this part a couple times. I can substitute in u here, but then I have a dx, and that's a mismatch of variables. So if I have a u squared, I want to be able to rewrite dx with a u instead of an x. So that's why this is important. So I come back down here, can I solve this for d of x, and then substitute that in as well? And the answer to that is of course, or why would we be doing this? So if I want to solve for dx, I'm going to do this the long way right now. Multiply both sides. So du equals 2 dx, solving for dx. So I'm dividing by 2, and I'm just going to rewrite that as 1/2. I don't know why my brain farted right there. So now I have something to plug in for dx, and I have something to plug in for 2x plus 1. So let me show you how we're going to rewrite this. We're rewriting it as the integral of 2x plus 1, which is u squared, dx, we're substituting that in for 1/2 times du. Now 1/2 can get pulled to the front, and what we're doing now is simplifying this problem so that we only have to apply the integral rule to u squared. I've already done all the back work, so watch how easy this is. If this is now the expression, so u squared is my derivative, so it's telling me to use it in terms of this variable, so I'm just anti-deriving u squared, so the 1/2 stays there. What's the antiderivative of u squared? 1/3 times u to the 3rd power plus c. That's it. So the answer is 1/6 u cubed plus c. So now I just need to take care of the fact that I introduced u. I'm the one who did that, so I need to undo it. So I go back over here. What was u equal to? 1/6. U is 2x plus 1 cubed plus c. And that's the same answer that we got previously, so we can see that this is going to work. Yay! Alright, I have a couple more examples. I'm going to work through these kind of quickly. I'm not going to talk as much, so you can pause or whatever you need to do. So I have 3 different of the similar types of problems, and then we're going to move on to more complicated ones. So again, 4th power, 3rd power, and if you look over there, that one's to the 9th power. So again, it's not, you don't really want to expand these. That would take way too much time. It's not something that you would necessarily need to do. So here's a much easier way to do it. So, u substitution. See? U substitution. So for each of these, the first thing I'm going to do is identify what u is. Always your first step. Second step is always to differentiate. So the derivative of u with respect to x of this one is 2. Derivative of u with respect to x is equal to 8. And the derivative of u with respect to x is -5. Now, I like this next step. Not everybody does it this way, but I feel like it's the easiest way. So we're going to solve each of them for dx because we want to substitute. So quickly, right? So dx is 1/2 du. Dx is 1/8 du. And dx is 1/5 of du. Now I'm just going to put everything together. The integral of u to the 4th, right? U to the 4th times 1/2 of du. 1/2 comes out. Du stays in. The integral of u to the 3rd, dx is 1/8 of du, 1/8 du. Integral of u to the 9th, dx is 1/5 times du. Now I just need to use the power rule. 1/2 times 1/5 times u to the 5th plus c. 1/8 times 1/4 u to the 4th plus c. And 1/5 times 1/10 u to the 10th plus c. I'm just going to simplify. So this is 1/10 u. I have to go back and substitute in 2x plus 3 to the 5th power plus c. I'm done. This one, 1/32, 8x plus 4 to the 4th. There we go. Finally, 1/50 u. Ugh. I also just realized I didn't, yeah, that should be negative. I don't know. What? Why am I like this? -1/5, -5, -1/5, -150, -5x plus 7 to the 10th plus c. So be sure your answers are always in terms of the variable that you started with. So even though we're using the u for substitution, we don't want to keep it as part of our answers. Alright, I have 3 more examples, and I keep forgetting to mention, but I hope you guys know by now that anytime we get an answer, we can always go back and check it by differentiating what we get. So if we differentiate our answers, we should get back to the original problem. So if we're not matching, then we know we made a mistake. Alright, so I put 3 new ones up here that are a little bit could be a little bit more difficult. So like number 1, for instance, already has a 4 that's there. So we're still going to apply our process. So what if we rewrote this one as 4 times the integral of u to the 3rd power dx, where u is 5x plus 1. The derivative of u with respect to x should be 5, which means that dx is 1/5 of du. So I can just go back here, I'm just going to replace dx is 1/5 of du, which means I have 4 times 1/5 out here. It's 4/5 du, right? So this is the problem that I need to apply an integral to. So the answer would be 4/5 times 1/4 u to the 4th plus c. 4/5 times 1/4, 1/5 u to the 4th, 5x plus 1 to the 4th plus c. I can check this. I can check it to make sure that I got the right answer. I'd have to use the chain rule here. 4 times 1/5. So here's my check. 4 times 1/5, 4/5, 5x plus 1 to the 3rd, times chain rule, multiplied by 5, plus c. Well, if I take the derivative of a constant, it's 0. So 4/5 times this 5 would end up being 4 times 5x plus 1 cubed. Bingo, we got it. So we know that this is the right answer. All right, so we're going to do the same thing for number 2, but this time I rewrote it, or I'm sorry, I included one that had a cube root in the denominator, so I'm going to need to rewrite it first. So first thing is a rewrite. It's the integral 4x plus 7 to the negative 1/3 power dx. So I know what u is, 4x plus 7. I know what the derivative of u with respect to x is. It's 4, and then I can say that dx is equal to 1/4 of du, and I'm ready to plug it and jug it. So this is really the integral, 1/4 times the integral of u to the negative 1/3 times du, because I already put my 1/4 right here. So now I just need to remember how to integrate something with a fractional exponent. I'm adding 1 to it. This is going to get a little bit confusing. We haven't done one of these in a while. So 1/4 times, if I'm adding 1 to negative 1/3, I'm adding 3/3 to negative 1/3, so I get u to the 2/3, and then I would want to multiply that by 3/2 plus c. So then I have 3/8 u, which is 4x plus 7, to the 2/3 power plus c, and we can check our answers. Running out of room. We check our answer. So I am 3/8 times 2/3, so that's 6/24, which is 1/4, times 4x plus 7. 2/3 minus 1 is the negative 1/3, times, because this is a chain rule, times 4, and then plus 0 because we're differentiating a constant. So you can see that this coefficient disappears, leaving me with just the original problem. So we did get it right again because we were really smart. All right, next one. All right, I'm going to rewrite this. 4x plus 3 to the negative 2 power u, 4x plus 3. The derivative of u with respect to x is 4. So I can solve for dx, 1/4 du. And I'm just plugging everything in. So I have the integral of u to the negative 2 power dx is 1/4 of du, 1/4 du. And I'm ready to anti-derive, adding 1 to it. So I have 1/4 times, I didn't need this yet, but u, negative 2 plus 1, negative 1 power, plus c. And then I should multiply this by negative 1 there. Nailed it. All right, so then we have negative 1/4. U is 4x plus 3 to the negative first power plus c. We can check our answer, see if we got this correct. So check. Oh, we're running out of room. We can check it. Negative 1 times negative 1/4 is positive 1/4 times 4x plus 3, subtract 2, negative 2 times 4, chain rule plus 0. You can see again, we got the right answer. I don't know if you guys can see that, but let's do. There you go. So we got the right answer. Here she is. And of course you can rewrite that the right way if you would like to. Yay! All right, final 3 problems for now. So I've included now some rational ones where the denominator is just raised to the single power, which remember we can't use our power rule for. We've got to use the natural log for. And then I also included one that has an exponential function in it. All right, so we're still going to use u substitution. So we know, for just really quickly, the integral of 1 over x. So we talked about this cannot just be, we can't rewrite this as x to the negative first power, because if we tried to anti-derive that, we end up dividing by 0, and it's not allowed. So we have, the rule for this is it's equal to the natural log of the absolute value of x plus c. So that's going to be important for number 1 and number 3. So we have to remember that. And then don't forget, if the derivative of e to the x is e to the x, and the antiderivative of e to the x is e to the x. There, however, becomes a problem whenever we have e to the 5x, right? So the derivative of e to the 5x, if we applied the derivative here, is not e to the 5x, it's e to the 5x, and then we use the chain rule. So those two things are going to come into play here. All right. So I'll work these out, slow it down, pause it, whatever you need to, or ask questions on our next Zoom class. So I'm still going to use my u substitution here. So u is 3x plus 2. The derivative of u with respect to x is 3. So dx is 1/3 of du. So when I rewrite this, the integral of 1 over u, right? And then dx is 1/3 times du. So now we're in one single variable, which is what we want. I'm going to anti-derive this, and we just saw the integral of 1 over u is the natural log of the absolute value of u. So it's 1/3 times the natural log of the absolute value of u plus c. 1/3 times the natural log of the absolute value of our u is 3x plus 2 plus c. Here is our answer. That's it. It's as easy as that. Next one. Again, I'm using u substitution. U, 5x minus 1. The derivative of u with respect to x is 5. So dx is 1/5 of du. Now I'm going to rewrite this. Now this already has a coefficient in front of it. So the first thing I'm going to do is rewrite it as 2 times the integral of e to the u power dx is 1/5. So I'm multiplying 2 by 1/5. Get 2/5 times du. So if you notice what I did, I made the inside function, right? The inside function is what u is. And that's actually been the case for all of these. It's the inside function that we're assigning the value of u. So something in a denominator, something in an exponent, something inside parentheses or inside a root. So those are all inside functions, and those are our u functions. That's what we're substituting for. So now I can anti-derive e to the u power, very easy. 2/5. The antiderivative of e to the u is e to the u plus c. So 2/5 times e to the u power is 5x minus 1 plus c. This is our answer. We could check it if we want to. If we wanted to check our answer, we would take the derivative of this function. So if we differentiate 2/5 e to the 5x minus 1, So that would be 2/5 times e to the 5x minus 1 times, we're using the chain rule here, times 5. So if we were to simplify all of this, and again, we know when we differentiate a constant at 0, 5's are going to cancel, leaving us 2 times e to the 5x minus 1. So we're good. This is a good answer. All right. So number 3, we have an 8 is the numerator and a 5x minus 3 is the denominator. So which one is the inside function? So we're moving down to the denominator here. So 5x minus 3, 5x minus 3 is u. The derivative is 5. Sorry, the derivative with respect to x is 5. So 1/5 du. So here, and if you go back to the previous video, we can say it's 8 times 1 over u du. 8 times 1 over u du. And now I can antiderive 8 times, what is the antiderivative of 1 over u? The natural log of the absolute value of u plus c. So we have, oh, I totally forgot my 5. My bad. Thank you guys for always putting up with my mistakes. I know they happen a lot. And then u is 5x minus 3 plus c. And that's our answer. We could check it if we want to. I'm getting a phone call. Unknown number. Gross. Don't answer that. We can check this if we want to. And we'll see that we would get right back to the beginning again because we're accounting for the chain rule being applied. So even though there's a 5 here, multiplied by 5, it's going to disappear. Drop it down to the denominator because we know that the if we differentiate the natural log, we get 1 over that argument. Okay, I think that's it for now. Miss you!